Hi friends, welcome to Civil Architecture Tutorials. Today the subject is regarding the lapping zone in a continuous beam. We know there are beams which are of less length and more length, means a lengthier beam will be there. For example, take the case of a continuous beam where the span or the clear span of beam is around 6 meter. So how we are providing lapping or lapping zones in a continuous beam? We cannot provide the lapping just like that in any beam, in a continuous beam. That is, as we know, the total length of a steel bar is 12 meter, and after that anyway we need to provide lapping. Lapping can be done by welding or by lapping with a binding wire or a coupler. That is another thing. So the lapping zones is focusing today. So let us take the example of this continuous bar. The uniform load is applying on the top of it. Uniform distribution load is applied on the top of it, and you can see this is a beam between columns at a distance of clear span 6 meter. So when the load is applying upon it, you know the compression will act on the top of it, and the tension will act on this side, that is sagging. It will go into a sagging phase, while at this junction it will go up, this will come down. So this is positive bending moment, and here it is negative bending moment, and the central part is the neutral axis. So this will be when a uniform distributed load is acting on it, the load distribution will be like this. So where we need to provide the lapping? Lapping is, as you know, it is a combination of, or one steel bar is combining with other steel bar. So as we know, this area in the central part of the beam, which is at down, we cannot provide any lapping, because if we are providing a lapping there, that will be the weakest point. So there will be a continuous bar at this point, because full tension is coming at this point. And also this side and this side also, there is shear, full shear. So this much area, it is heavily loaded, high shear is there, so there also the lapping should not come. So then the second option, the other option, only option that we are having is, if it is 6 meter, we can divide by L by 4, L by 4, L by 4, L by 4, that is 1.5, 1.5, like that it can be divided. So this will be the center part, okay? And we know that we cannot provide lapping at the center part, and we cannot provide lapping here at this side also. I mean the bottom bar I am telling. This side we cannot provide, and center part also we cannot provide, because these two areas have high tension are acting on that particular surface. So the only area left is this side, and here also this side, okay? So how to get the length at which this lapping should start, that we can know. That is, we need to take the effective depth of beam. Effective depth of beam means, if this is the beam, the effective depth is the total depth of beam minus the cover. The cover here, there is a cover, minus cover, and minus half of the dia of the steel bar, which is coming in this area. That is, here it is, if it is around 300, the width of the beam or depth of the beam is 300. 300 minus 25 is the cover width. So 300 mm minus 25 mm minus 6, if it is 16 bar, 16 mm by 2. So that is the effective depth of this beam. That is 300 minus 25 minus 16 by 2 into 2. That much distance we have to take from this junction of the column up to wherever it comes. From there only we can go for the lap. I think, anyway, again I will say the formula. The effective depth of the beam into 2 is the point from which we need to start the lap, here or here. So again, effective depth is total depth of the beam minus the cover minus half of the dia of the steel rod that we are using at bottom, okay? That into 2. That much distance we have to take from the junction of this column to here. Here it comes at 2 into 300 minus 25 minus 16 by 2 is 534 mm. So we have to take 534 mm from here to here, and from there, that point, after the 534 mm, we can start go for lapping. Because why we omit this area is that this is area where the shear load is coming. So don't think of giving a lap at this area, it will break. That much shear force is acting at tension is acting at this area, because the column is there and we cannot provide the center too. So from the center you have to move away, and also from this corner also you have to move away, and at this distance, ft depth of beam into 2, then you can provide the lap here or here. These two sides we can it is possible. So lapping should come into that area only. So now we will discuss regarding the topmost area, or where the lapping in the top bar, where we can provide. Here in this center part, as you know, the tension is fully coming at this downside area, the topmost area. We are safe to provide the lapping zone for the top bars. So we can provide a lap at this middle bar at top. There is no problem in providing lapping here, but in down we cannot provide. That is the thing that we have to remember. And again, regarding how much is the lap length, lap length is also a thing which is very crucial when we are providing the lapping length. Lap length is always equal to or greater than the Durban length. Durban length, as you know, the anchorage length from here to here, with the formula is 50d. So the lap length can be 50d, or it should be greater than 50d. It should not be less than 50d. So that much lap length we can provide here, and in top here also, and here also bottom, here also 50d or more than 50d. Reinforcement details here, the end of the lapping zone. So this is the topmost lapping zone here. We can provide, this is 50d the lap length, and the lapping comes at the exactly at the center in the topmost bar. But it comes in the bottom bar, like a given here. This should be at a distance of 2 into ft depth of the beam, that it starts here, and then lap length should be 50d or more than 50d. So these two are the lapping zones in a beam. And also one more thing to remember is that stirrups we have to give in these lapping zones should not be more than 150 mm. Okay, 150 mm should be the minimum stirrup spacing that we have to give in these lapping zones. It should not be more than 150 mm. So I think by today's video you understand the lapping zones and the lapping length and the stirrup spacing that we have to give in a beam. I'll come with a new video with new subject. Till then, goodbye. Please subscribe, share and like my channel. Thank you very much.